All right, it's the final countdown.
It's the final countdown.
Problem 12 is very important, and even if you've had some trig experience before, it's going to make you think, okay? So, part A, theta. Theta is a Greek letter. It's just a regular letter like A, B, C, so if we draw a triangle and we label one of the corners A, capital A or capital B, theta is the same thing, okay? So theta is the angle between a line segment joining the origin and a point labeled P at 4, 3. So 1, 2, 3, 4, 1, 2, 3. Here's point P. Here's the origin. Theta is going to be this angle right here. We do know this length is 4, so we might as well label it. And I know that this length is going to be 3. Don't know the hypotenuse. They want us to find cosecant of theta. So cosecant of theta from this corner means I need the hypotenuse over opposite. We don't know the hypotenuse. What we could do in this case, there's a few things we could do. There's a very horribly long way to do this, which would involve you using tangent, because we have the opposite and adjacent, and then you find the angle using your calculator, and then you go ahead and set up another one, like sine, and then you can get that answer from there. It is too much work. The best way to do this is because I have two sides already, I can use the Pythagorean theorem, right? So C would be the square root of 3 squared plus 4 squared. C is the square root of 25. C is equal to 5. So this ends up being cosecant theta is equal to 5 over 3. And that's all I want. I just want you to find me that setup. So what's important though is to organize yourself in a problem like this. You need to make sure that and I should have probably mentioned this is going to be in quadrant 1. I didn't because of the point. The point automatically forces you to be in quadrant 1. Okay, so be mindful of what quadrant you're in. Draw it out. Make sure you use the geometry that's involved in the graph, and then label whatever you have. See what you can set up, and then take it from there. Don't forget, you can always use sine and cosine, but the Pythagorean theorem is definitely something you want to keep in mind. Give the signs of the 6 trigonometric functions for each angle of 2 pi over 3. So we have sine, cosine, tangent, secant, cosecant. Okay. Now, let me ask you this. 2 pi over 3, what quadrant is that in? Because the quadrant that it's in is going to affect the signs. Hopefully you've noticed that it's quadrant 2. Remember, all students take calculus. So in quadrant 1, all of them are positive. In quadrant 2, students, S, only sine is positive. So in quadrant 2, sine is positive, and therefore the evil cousin is also positive as well. Everybody else would remain negative, including the reciprocal ones. So tangent and cotangent would be negative. Cosine and secant would be negative. Okay, so use your unit circle for that. Look at the quadrants, look at the signs, and then just pair up the cousins with their cousins. Part C, we have, they gave us cosine in quadrant 3. So let's go ahead and draw quadrant 3. This is the x-axis, this is the y-axis. Notice that the x and the y are both going to be negative because we're in quadrant 3. Okay, negative 3, 1, 2, 3. And in case if you're not aware of what cosine means, right? Cosine means that it's the adjacent, or the x-axis, over the hypotenuse. So don't go drawing 5 y down, because what it is it's 5 hypotenuse. So we have this length right here. This length is a 5. The radius is 5. Okay, so this is a negative 3. This is a 5. We need to find tangent. Now, once again, because we're given two sides, we want tangent. Tangent of theta is going to be opposite over adjacent, right? We need to find the opposite. We need the opposite. The adjacent is negative 3. We need the opposite. But once again, they gave us two sides. Okay, if they don't give you two sides, you can use another trig function to find the missing side, right? So you can use sine or you can use a cosine. But in this case, we are given two sides. So we can use the Pythagorean theorem once again to go ahead and find this missing side. Okay, so if I do that, minus -3 squared, I get that b is 25 minus 9, and that's square root of 16, which is 4. Now the math gives me a positive 4, but in reality this has to be a -4 for many reasons. One, we're in quadrant 3 and it's going downward. Two, when I go ahead and plug this in for the opposite, I need to get a positive answer out of it all, because we said that in quadrant 3, tangent and cotangent are positive. Okay?